Hello everyone, my name is Matt and I will be taking you through my poster on exploiting sparsity for neural network verification. Seeing as the first step in reading a paper is going through the conclusion, I thought I would start at the end of the paper. We use ideas from causal sparsity to show that the computational time to solve this semi-definite program can be improved dramatically over traditional second-order solvers. This graph summarizes these results by showing the difference between computational time of solving the semi-definite program with and without causal sparsity. The figure on the left shows what happens when we vary the number of layers in the network, and the figure on the right shows what happens when we vary the number of hidden units. The general problem of verifying a neural network is to ensure that all inputs map to a safe set of outputs, SY, which is a superset of all possible outputs. We consider a feed-forward, fully connected neural network written in matrix form, where WK and BK are the weights and biases of the k+1 layer in the network. We can convert this verification problem into a semi-definite programming framework, which is shown here. I would highly recommend reading our paper as well as the relevant reference for more details about this. Note that this framework scales badly when the neural network size becomes too large. So what is causal sparsity? The concrete definition is that any cycle of length 4 or greater has at least one chord. Think of a graph made up of purely lines and triangles. By representing the matrix as a chordal graph, we can decompose the semi-definite program constraint into smaller constraint matrices, which can greatly improve the scalability of the problem. Since the neural network has an intrinsic cascading structure, we expect there to be some sparsity in the linear matrix inequality constraints. This structure is shown here, and we can see that it exhibits a block arrow pattern, which is known to be causal. Therefore, we can use causal sparsity to greatly speed up the computational time to solve the semi-definite program. Thank you for listening. Please let me know if you have any questions.